Hello everyone. In this video let us understand a pure capacitor behavior when we are going to apply an AC voltage to it. In the previous video we have seen pure resistor and pure inductors. Let me write the circuit for this. So pure capacitor will be considered as a parallel plate capacitor with capacitance C, and I am applying an AC voltage to this. A AC voltage will be represented like this. So here the AC voltage is V is equal to Vm sin omega t. This is the AC voltage I am applying. So AC voltage will be a sine wave and it is having a maximum value of Vm. We can observe here from the expression itself, we can say Vm is the peak voltage and this is the instantaneous voltage V. Because of this input to the capacitor, current flowing through the circuit will be in this direction, and let me write the current, AC current flowing through the circuit is I. We can write the current flowing through the circuit in a capacitor is dq divided by dt. Q is the charge. So Q is equal to C, that is capacitance, into the voltage divided by dt. Here I becomes C times d divided by dt into Vm sin omega t. Vm sin omega t is the expression I will be having for V. So it becomes C into Vm into omega. For sin omega t it is cos omega t. So C into Vm omega cos omega t. So let me write it as omega c into Vm. I am going to write this in terms of sine. Sine omega t plus pi by 2 is same as cos omega t. Right? This is the current expression I. Here what is this omega c? This omega c can also be written as 1 divided by xc. xc is the reactance of the capacitor. Here xc is the capacitive reactance, we can say. Okay, and if you observe this expression and this expression, now the voltage and current expressions, if you observe, it will be having a phase difference of plus 90 degree, right? Here it is sin omega t, but here it is sin omega t plus pi by 2. So there is a phase difference between the current and voltage of plus 90 degree. We can say current is leading. Now let us plot that in a phasor diagram by taking V in x-axis. Vm is the maximum voltage we are applying. So if we write current, it will be exactly 90 degree. Why? Because it is having plus pi by 2. Plus pi by 2 in the sense the difference between these two is plus 90 degree. So the phase difference is plus 90 and the phase angle between these two is plus 90 degree. And here, since it is having a plus 90 degree with respect to current, current is leading here. Current is leading the voltage, right? In the previous case, in the inductor, we have observed current is lagging behind the voltage. Here current is leading the voltage. So again, if we plot that with a current and voltage signals, this is the voltage signal and this is the current signal. You can observe at the origin, when these two are coming at the origin, we will be having 90 degree difference or pi by 2, we can say. And current is, it will be having positive value compared to the voltage. So we can say current is leading the voltage. Voltage is lagging behind. So current is leading the voltage. And for this, let us derive the expression for power, how the power dissipation in the capacitor will be. Let me write P instantaneous value first. P instantaneous value is equal to, that means P AC, power AC is equal to V into I. What is V here? It is Vm sin omega t into current is Im sin omega t plus pi by 2, right? So it is Vm Im sin omega t. Sin omega t plus pi by 2 is cos omega t, right? So it is Vm Im divided by 2 into sine 2 omega t we can write. Okay, so this is the instantaneous value of power. So if you write the average power, we are interested to calculate the average power. So average power is that we need to integrate from 0 to 2 pi the same expression. If we integrate again the 2 times the frequency component, we are integrating from 0 to 2 pi, so it becomes 0. So P average will be equal to 0. It means what? The power dissipation or power consumption by the capacitor is 0. There is no power consumption by the capacitor. Similarly, power dissipation in inductor is also 0, right? Power dissipation in capacitor is also 0. So similarly, power dissipation in resistor is, that is Vm Im divided by 2. So in the next video, let us see the combination of RL and C circuits. If R with L is used in series, R with C is used in series, and RLC are used in series, how the current and voltage expressions will be, and let us write the phasor diagrams for that also. Thank you.